The 2020 National Electrical Code, or NEC, specifies requirements for grounding electrode systems. If the only grounding electrode available is a metallic water pipe, there are distance limitations between the service and the grounding electrode. NEC Article 250.52 8.1 addresses water pipe electrodes. It states that the grounding electrode conductor from the service equipment to the grounding electrode must be as short as practicable. However, it is generally understood that the maximum distance from the service to the point where the grounding electrode conductor connects to the water pipe is 6 feet, or approximately 1.83 meters. This requirement is implied through interpretations and best practices within the electrical industry, aiming to minimize impedance and ensure effective grounding. The reason for this distance limitation is to maintain a low impedance path to ground. A longer conductor increases impedance, which can hinder the effectiveness of the grounding system in clearing faults. Lower impedance allows for a more rapid and effective path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. When upgrading a service where a water main is the primary grounding electrode, and there is no safe location for ground rods, you must adhere to this distance requirement. Firstly, locate the point where the metallic water pipe enters the building. Secondly, determine the closest accessible location on the pipe within 6 feet of the service equipment. Thirdly, ensure that the water pipe is indeed metallic and makes direct contact with the earth for at least 10 feet. Fourthly, verify that there are no insulated couplings or sections that would interrupt the electrical continuity of the pipe. Fifthly, if the water pipe does not meet the requirements for a grounding electrode, you will need to supplement it with another approved grounding electrode, such as a ground rod or ground ring. When installing the grounding electrode conductor, use appropriate connectors listed for grounding and bonding. These connectors should be made of materials compatible with both the grounding electrode conductor and the water pipe material to prevent corrosion. The grounding electrode conductor should be sized according to NEC Table 250.66, based on the size of the service entrance conductors. The grounding electrode conductor must be securely fastened to the water pipe to ensure a reliable connection. This can be achieved using grounding clamps or other listed fittings designed for this purpose. The connection point should be accessible for inspection and maintenance. It's also crucial to protect the grounding electrode conductor from physical damage. Where exposed, the conductor should be routed in a manner that minimizes the risk of damage from impact or abrasion. Where necessary, the conductor should be installed in conduit or other protective raceway. In addition to the water pipe electrode, consider bonding all metallic piping systems within the building. This includes gas pipes and other metallic conduits. Bonding these systems together creates a common ground potential, reducing the risk of voltage differences and potential shock hazards. The bonding jumpers should be sized according to NEC Table 250.102 C1 and connected using appropriate bonding clamps or lugs. Ground rods can supplement a water pipe electrode if the water pipe is not continuous or does not meet the 10-foot earth contact requirement. Although a safe location for ground rods may be difficult to find, alternative locations should be explored. These could include areas along the building perimeter or in remote locations away from underground utilities. If ground rods are used, they should be installed at least 8 feet in length and driven into the earth to a depth of at least 8 feet. The ground rods should be spaced at least 6 feet apart to minimize interference between their grounding fields. The grounding electrode conductor from the service equipment to the ground rods should be sized according to NEC Table 250.66 and connected using listed grounding clamps. If multiple ground rods are used, they should be bonded together with a bonding jumper sized according to NEC 250.64. A ground ring is another option. A ground ring consists of a bare copper conductor, at least 20 feet in length, buried in direct contact with the earth at a depth of at least 2.5 feet. The ground ring should encircle the building or structure. The grounding electrode conductor from the service equipment to the ground ring should be sized according to NEC Table 250.66 and connected using listed grounding clamps. A concrete encased electrode, often referred to as a U for ground, can also be used. This consists of at least 20 feet of bare copper conductor, at least 4 American wire gauge in size, encased in concrete. The concrete must be in direct contact with the earth. The grounding electrode conductor from the service equipment to the concrete encased electrode should be sized according to NEC Table 250.66 and connected using listed grounding clamps. Regular inspections of the grounding system are essential to ensure its continued effectiveness. These inspections should include checking the condition of the grounding electrode conductors, connections, and electrodes. Any signs of corrosion, damage, or loose connection should be promptly addressed. The resistance of the grounding system should also be tested periodically to verify that it meets the requirements of the NEC. High resistance indicates a potential problem with the grounding system and should be investigated and corrected. If the resistance exceeds 25 ohms, additional grounding electrodes may be required. In summary, the maximum distance from the service to the water pipe grounding electrode is generally considered to be 6 feet. The grounding system must comply with all applicable requirements of the NEC, including conductor size and connection methods, and protection from physical damage. Regular inspections and testing are essential to ensure the continued effectiveness of the grounding system. If there is not a safe location to drive ground rods, alternative grounding electrodes such as ground rings or concrete encased electrodes should be considered. Proper grounding is critical for electrical safety and helps to protect people and property from the hazards of electrical shock and fire. Understanding and adhering to the requirements of the NEC is essential for ensuring a safe and reliable electrical installation. The grounding electrode conductor must be continuous and without splices or joints, unless specifically permitted by the NEC. If a splice is necessary, it must be made using an irreversible compression connector listed for grounding and bonding. The grounding electrode conductor must be securely fastened to the building structure to prevent movement or damage. This can be achieved using straps, clamps, or other listed supports. The grounding electrode conductor must be protected from physical damage. Where exposed, the conductor should be routed in a manner that minimizes the risk of damage from impact or abrasion. Where necessary, the conductor should be installed in conduit or other protective raceway. The grounding electrode conductor should be accessible for inspection and maintenance. The connection point of the grounding electrode should be readily accessible and not obstructed by other equipment or materials. The grounding electrode conductor should be identified with a permanent label indicating its purpose. The label should clearly state grounding electrode conductor or similar wording. The grounding electrode conductor should be installed in a neat and workmanlike manner. The conductor should be routed in a straight and orderly fashion, avoiding sharp bends or kinks. The grounding electrode conductor should be installed in accordance with the manufacturer's instructions. The instructions should be carefully reviewed and followed to ensure proper and reliable installation. The grounding electrode conductor should be inspected and tested by a qualified electrician. The inspection and testing should verify that the conductor is properly sized, connected, and protected. The grounding electrode conductor should be maintained in good condition. Any signs of corrosion, damage, or loose connection should be promptly addressed.